Good evening, everyone. It's my pleasure to welcome you all to the fifth day of the Faculty Development Program on Responsible AI, organized by PSG College of Technology, Coimbatore, sponsored by AICT ATAL. Let us begin with a thoughtful quote today. Education is the passport to future, for tomorrow belongs to those who prepare for it today. This quote captures the essence of why we are here today, to prepare ourselves and others for a future shaped by artificial intelligence. It's a honor to introduce our esteemed speaker for today, Mr. Pichayappan, data scientist at Podcast. He's a data scientist there, software as a platform providing AI-driven logistics and supply chain intelligence. It's a company that is basically located in Singapore. It has recently raised around 7 million in its Series A funding. In his role, he focuses on analyzing large-scale automatic identification system and geospatial datasets as well as unstructured data to develop models that detect trends and anomalies, ultimately improving key performance indicators in the shipping industry. He holds a Master of Computing in Computer Science from National University of Singapore and bachelor's degree in Computer Science from PSG College of Technology. So it's worth mentioning here that he is one of our best students who passed out from the Department of Computer Science and Engineering. And I'm very happy that I've handled a class for him. His research experience spans a variety of domains, including malware detection using AI, failure reduction in edge devices, equitable order matching systems in stock exchanges, weather and port operation optimization, and domain-specific document and contract analysis with generative AI. At Podcast, he has been instrumental in advancing responsible AI by emphasizing model explainability and shifting away from purely black box architectures. Leading research efforts in this area, he focuses on ensuring transparency, accountability, and fairness in AI driven solutions. During this session, he will share general guidelines for responsible AI alongside specific some examples from his professional experience. I welcome you for this session and over to you.
Yeah, thank you, Professor. I see 45 people here. Should I start?
You can continue, sir. Probably people will join. Meanwhile, I'll put the messages in the group to join immediately.
Okay, sure. So for people who are already on the Zoom, in the Zoom chat, I have shared a Slides app link where you guys can just pop in and ask questions if you'd like. I'll try handling them as I go or after my speech is done. My my specific my specific presentation is quite long, so I'll see how that goes. Okay, so I guess I'll begin. Uh, yeah, so I'll be talking about responsibility. I understand that as part of the FDP, like multiple people have talked about it, but I still give an overview and some aspects of what I feel are important in this space. It's quite new, but still pretty important at this point, given like how fast regulations are changing and like how fast competition is as well. So this would be like my context. I talk a little bit about me, intro to responsible AI, technical challenges, what we expect from following responsible AI, and then how we work on explainability specifically, because that's like important part of what I work at podcast. So I'll spend more time on that very specific outcome. And then what my company does and some of the policy implications that we are facing around the world right now, and then some of the best practices, and then some research areas that I keep up with, and I'd recommend like you guys find your niches there, and then a corporate adoption of responsible AI, and then a case study before I close out for QA. So initially, this is me, Pitch Up, and you guys can call me Pitch. I did my bachelor's from PSG Tech. Surya ma'am was one of my teachers. She taught me software development. Uh, and then I went on to do my master's in National University of Singapore, where I mastered in like core computer science, but a bunch of my specialty courses were in AI, and AI was popping off, so I decided I'll jump in on a startup that was working on it. Right after school, I joined like a company called Podcast. We just finished raising our Series A, and our Series A, we raised like $7 million in Series A. My research experiences, when I was at PSG, I was a student researcher with a couple of professors at the uni. And then during my master's, I spent the complete 2 years also working as a researcher at the FinTech lab. My previous research experiences were like in cybersecurity, blockchain, financial markets. Currently, being a data scientist, I usually just work in AI and a large section of engineering as well. So in AI, Gen AI is what I've recently been working on in R&D alone. Classical ML, optimization, and explainable AI, I work in production systems. And what we do at Podcast is we track ships and containers, make sure we get data from like over 2000 different sources. And then we predict like arrival times at ports, delays, demand forecasting, carbon emissions, and a bunch of other things. You guys can visit our website if you'd like to know more. It's quite a cool company. We're small, but we're growing. And then for an intro to responsible AI. Responsible AI is a relatively loose term that everybody just talks about in a different way. So every company has a different definition, but all of them basically get to the same core. According to me, and at Podcast, at least what my team agrees on, is responsible AI should mostly have four things. For a much more formal definition, in a couple of slides down, I'll split it into seven. But at this point, just four. One would be like AI systems that will need to be ethical. They'll have to do what they're told and all that. Kind of like the friend who returns the pens. Transparent, definitely not like all the sorts of excuses that I used to give at uni or any student for the matter. I'm sure everybody here has faced that. So transparency, fairness, it has to be fair, though fair is subjective. We have to give a way of measuring it objectively. And then safe. I'll talk about it in detail, but first let's go to why does responsible AI even matter? Two big reasons. One, AI is already everywhere. We've got ChatGPT for essays, homeworks. I know people at NUS right now who just complete their assignments using Cursor AI, and they start like half an hour before submission and they usually get full marks. So that's there. You've got it on your Netflix recommendations. You've got like face locks on your phone and a bunch of other use cases that I'm probably missing here. And the second part being like stakes are quite high. Like we are introducing AI into complex tasks, which include like financial assessments, supply chain, that's what I work at, and healthcare decisions. So it's important to like keep an eye on how we develop this. A bunch of motivations behind responsible AI. One would be ethical concerns, like uh, is it okay to kill people, not kill people? That sort of ethical concerns. AI definitely has such big questions. Business stability, because if AI is not ethical enough or is not within a framework, it impacts business way too much. Some people think that's good, but institutions and systems are what keep our world running, and messing them up too often is dangerous. The third is regulatory compliance. Three is probably the one thing that forces everybody to follow this. The other three are more of what you'd like to do yourself. But regulatory compliance, if you don't follow the rules, you don't get to publish your models and make money. And the fourth being social impact, which is important. AI could be used in elections, it could be used in misinformation, deepfakes, a whole bunch of use cases. So it's important to be responsible with the technology that we have. So one very popular example of unethical use of AI, which was like a long time ago, this was 2014, Brexit. For guys who knew, there was a company called Cambridge Analytica, which just scraped all of Facebook for the UK, identified all the voters, looked at what they liked, did not like, and basically used that to create profiles. And then from profiles, figured out how to subtly influence them so that they would vote to leave the European Union. And they succeeded. Like, I think they succeeded barely by like 50 point some percentage of the votes, but they did succeed. And they went to EU court and British court. The company is no more. But what they did showed in a large scale how unethical AI, it was a very small group of like, I think less than 50 people, just with data capabilities in mind. And like a pretty wrong direction who were able to like sway an election of like 8 million people. So that's where this becomes quite important. Other examples that already exist in today's world, one would be facial recognition bias. The easiest way, people with darker skin, cameras don't capture as easily, while some people try to defend that there could be like physics reasons for that. It still is the matter that like darker skin people are find it more difficult to work with facial recognition systems. So we'll have to improve the systems to include everybody. Hiring bias, which is using like AI to automatically pick resumes. It seems necessary in today's world, given how many applications do come in for postings, but it definitely has like unethical considerations. And then loan approvals in banks, and then deep fakes that we've seen like all around India as well. But I picked a deep fake of Obama just for like an example. And in terms of core principles of responsible AI, there are a bunch of different companies who follow different definitions. I picked one that's got 7 definitions because it seems to be like quite broad and uh, I mean quite broad in its uh, domain, so it makes it easier to like keep track. So one would be an AI that you build has to be accountable and transparent. You need to have a way to like figure out why the AI is telling what it's telling, and then everybody, all the humans should understand what the AI is doing. And if they are talking to an AI, like transparency becomes super important. If an AI tells something bad, who is responsible? Like if you build a system and then you give it to somebody else and it messes up, if a car company builds a car and they give it to you and then like the safety systems did not come out and the car crashed, who is responsible? In the old cases, the company is responsible, but with AI, given that it's just a few MB to a few GB that you can just transmit, it becomes a lot more tricky to like narrow down, specifically for the micro models. Two would be explainable and interpretable, which is like kind of similar. When AI messes up, somebody needs to have answers. You cannot just believe in a black box because it can have bias in how it's making the decision. The third would be a fair and unbiased AI systems, which is a very, very tricky system to solve. There are few examples, but this is like more or less almost always like never fair. We just try to reduce bias as much as possible. So if it is a loan system, you try to make sure that it does not discriminate people from tier 2 and tier 3 cities, which most banking systems at this point actually do, because that's the sort of data quality they have, which for examples, I'll come later in the presentation. And then privacy protection. So data has to be protected. If you trained LLM, let's say, with conversations of like 50 people, and then I ask it to replicate a conversation, we have to make sure that it is not just spitting out a conversation that was already there in the training set. So that is basically a breach of, how to say, yeah, a breach of trust, or a breach of like why you got the data for. So that's one important thing. Another would be secure and resilient. AI should be able to like work against cybersecurity threats, adversarial data, system failures, or data loss. This is mostly managed with like traditional computing concepts itself. Another one being valid and reliable. We need to make all systems have like a certain element of inaccuracy, but we have to make the AI as reliable as possible, specifically if we put them in like more important situations. And the final being safe. Safety, not from a technical sense, more of a societal sense. AI has to work in protecting users and society from potential harm. We definitely shouldn't build an AI that identifies like dissidents. If we build something like AI which is unhappy with governments, like imagine what happens if like China or Russia get access to that. So that's one example, but there are more. And now for a few of the technical challenges in AI. While I did go through 7 pillars, for the sake of the topic, I'm just sticking to like the few pillars that I've worked on or that I've got like more of a technical idea with. One would be bias and fairness. So it's a very huge elephant in the room. It's something everybody agrees exists, but nobody knows how to deal with. So one of the oldest examples of like a data bias would be the picture of God in the Christian sense. All through the Vatican, through everything, it's a very narrow definition of a Renaissance picture of God, which was what Michelangelo and all the other artists then were like set to draw. Another good example is if you go to like the Sistine Chapel or like the Anglican Chapel or a couple of chapels in France, you'll see Noah having horns, which is because like some interpretations of the Bible used to like draw Noah with horns. And this basically ended up propagating through the system. Now that like nobody knows why it started, I mean, now we do, but it still does not change the fact that there are a lot of systems where the bias has been built in. So it definitely is there with like societal data. We have like implicit biases that we already have of multiple examples. So if a student just games too much, we automatically write him off, which I personally, being a gamer, think is unfair, but that's one of the examples. So we've got societal data bias. We've got algorithmic bias as well, which is when the algorithm itself has a bias. This could be related to like you pick a very basic model, like a linear regression, and it does not capture like certain biases, or it's like prone to certain biases, which also ties into sampling bias and labeling bias as well. So you can just label multiple people in America. Almost everybody in Asia is just labeled as Asian Americans. So if you're trying to build a system for Asian Americans in America, there are like huge cultural differences between Vietnamese and Laos and Chinese and Korean. But in the US systems, they're all just Asian Americans. So that's also a labeling bias. Another would be privacy and security. So passwords just aren't enough anymore. So different people need to have access to different types of data. So you need to have data access control. There is also cross-border data regulations, which dealing with it is a pain with the systems that I'm building. Like certain companies, I mean, if I'm building for companies in the EU, which I am at this point, the data cannot leave the EU. So the way I build it is I keep all the data in an AWS cluster in the European Union, and I VPN into one of the systems, EC2 systems there, and I just build it there and make sure the data never leaves the state, leaves the region. So there are a couple of the problems, another being scalability versus ethics. So move fast and break things and do no harm. Move fast and break things is what Facebook used to have, and do no harm is what Google used to have. But when both meet together, there is definitely a problem. So if you want your system to be scalable, the easiest thing is to have like small models. That's like one way. But if you have small models that focus on accuracy, you might have to like give up on interpretability, which reduces how responsible you are, but it is definitely cheaper. Building like a 7 billion model as opposed to a 70 billion model is very different. You can train a 7 billion model with a laptop you have at home. But if you want a 70 billion parameter model, you're going to have to rent out AWS clusters, and it's probably going to cost you like 30 to 40 US dollars every experiment. So after a few months, you would have spent a few $100s on just building a model. And you've also got real-time constraints where you've got like resource limitations. You can't always make multiple API calls. If you're using OpenAI or something, you've got rate limits. You would like to make 5 different calls to make sure it's very safe. But if you make 5 calls and they give you a rate limit of like 60 calls per minute, you basically end up with only 12 predictions or 12 workflows in a single minute, which is like not great if you want to sell a product. So those are cases where you have to like compromise, and another being like process real-time decisions as well. Like if it's time sensitive, your AI can't take too long. So those are other considerations. And a final thing being like theory meets reality, which is an implementation challenge. So you've got a lot of technical debt, like legacy systems, which have been building up from the 1990s, 2010s, and none of them basically had any sort of monitoring or other systems built in because people used to build it as they went. They need something, they just build something up as a hobby and continue using it. But 5 years later, you see that all of it is just working very, very badly. And now making any change will just destroy everything. So those definitely exist, and working across them for ethical consideration, not all companies or teams have the willpower or the resources to do it. Most cases, they don't have both. And practical considerations as well, like if you're working on ethical parameters, do you change your ethical parameters? Like if the law of the land changes and they change, I don't know, something like inheritance law, like your model has to change, your ethical parameters have to change, and that's a tricky one to deal with. Another being model retraining frequency. If it's a very, very large model, you don't want to train it every week, but training it every week will make it updated with ethics. So that's also a concern. Next is intended outcomes of responsible AI. So it's not just about what it can do, it's about what it should do. One would be transparency and explainability. So these are a few of the things that the models that I build, I mean, at least my company builds. We've got an RFC where every time I create a new model, I fill up all of these things. So I basically copy pasted it from my company's Notion. So it might look a little bit different. So one thing would be transparency and explainability. So if I've got, if the AI gives me an output, so I make predictions for ships. So if I tell a particular ship is going to arrive at Chennai in 4 days, but if they're thinking it would arrive in 3 days, I kind of have to be able to explain, at least to an extent, why it was delayed by a day. So there is also like some things where there is a new act in the EU, the EU AI Act, which forces audit trials for regulatory compliance, where explainability is technically the law of the land in the European Union now. Another being fairness and equity, which basically means like, at least in the shipping sense, I have to make sure that just the bigger companies, like the top 10 shipping companies in the world account for over 90% of all the ships. But just because that's what they account for, I cannot build models that will just be unfair to the smaller ships. A couple of reasons, one being, yes, fairness from a technical sense and everything. But another, if I build models for like the smaller disenfranchised shippers, they are willing to use us more. And that also means more revenue. So fairness can help in revenue generation as well. Side note, but it can. And yeah, bunch of other things like identifying biases. We've got a couple of like automatic bias identification systems built in that help us identify if bias is tilting, and then we go into model retraining exercises. Another being accountability and governance. So if our model makes a mistake, who is responsible for it is a big question. Assume that there is a trader in Chennai who basically has to send a truck to the port. He was supposed to send, the ship was supposed to arrive today, and we said it would arrive tomorrow. So he decided not to send the truck, but the ship anyway arrived today. That means like he is paying a fine for not picking it up on time. And in those cases, who is responsible? Is it us? Is it them? All of these things kind of have to be like consolidated and made very clear. I'm not saying that we are responsible, but we do have a share of responsibility. So you basically talk with your stakeholders to figure out like what sort of accountability you're willing to take on, and define the KPIs and monitor them every day. I've got like, my company has a dashboard with like over 500, 600 alerts that a bunch of us just open every morning just to see what went wrong and try to fix it as soon as possible. Another being privacy and security. So our being in shipping, we get like extremely sensitive shipping data, like what is being shipped, where is it being shipped, and what sort of price or gross value it has. And all of that has to be safe, even if we train our models with it. So ensuring that such data does not leak at the end of the models, or there is no way to uh, get them out of the model. We take a couple of steps. One being like we try to limit the purpose of the model to a very narrow margin so that it does not do the bad things that we are afraid of, and a bunch of other things as well. It's a pretty interesting space. And the final being sustainability. So this is not something that, I mean, this is something that we are thinking about, in at least in terms of shipping. We do carbon emission calculations, but In terms of AI, we haven't really begun working at it, but we have to. Where like training the model for longer, building a bigger model, hosting a bigger model, all of these cost more, not just in terms of money, but also in terms of carbon emissions. And carbon credits are not really a solution. So trying to be sustainable in what we do is important. We plan on working on it, but we still haven't. Another thing being the importance of explainability, which, yeah, I think I did cover already, but this is like a more detailed coverage. So one would be a reason for why we need explainable AI. I've already covered a little bit, like a computer saying no cannot be enough. And there are legal requirements, which is why we have to do. And we've got like a huge problem with this. So if you build like extremely complex models, you get to have like quite good performance with it, but they're not as explainable as a simpler model. Like if you build a linear regression model, you can just extract the equation and run it to say, this is why I said this is what's happening. But if you're building like a very huge deep neural network, if you want to extract the equation out, it's something with like, I don't know, 10,000 parameters. Like you're not going to be able to like explain anything. So there are a couple of other ways you can work with it, but it's still difficult. So this is the extremely classical accuracy or interpretability trade-off. And in some cases, we'll have to sacrifice one for the other, which, yeah, a couple of examples of how we do it. So a couple of things that so sharp and lime values are both like quite popular methods that most of you probably should have been exposed to. They're extremely old methods that have been like around for longer. I mean, like as long as AI has probably. Both of them basically, you give the input features and you give the output. Both methods basically try to create simple explanations. In different methods, sure, Sharp tries to do it from like features, like importance of feature kind of method. And Lime basically tries to go for it from a more translation method, like this is why this happened kind of thing. More of like a path-based method. But both of them work very well as long as like your use cases is quite limited. Obviously, we can't use this to explain the output of ChatGPT, but if it's the output of something like something like a tree-based model, both of them are like more than enough. They're actually really good if you're using tree-based model to give like an explanation to a consumer. Works really well. And a couple of other techniques would include integrated gradients, rule-based explanations, and counterfactual explanations. I'd recommend people read up on it separately. I'd be happy to cover it in a while as well if necessary, but yeah. And a couple of practical examples of how these have been implemented. So in healthcare, so when you get like disease predictions, so there are already systems where once radiologists get it, radiologists write their own systems, but there are also AI tools. I think the Mayo Clinic in the US is experimenting with a couple where the AI reads the radiology reports and it also comes up with its own sort of explanation. So it identifies cysts, identifies tumors, does all that. But after the identification, explainability here is important because the AI also has to say why it says that the scan says that there's a cyst or a tumor, like identifying the accurate location, showing the bulge, showing the rate of growth, for example. So that's a place where explainable AI is super important. Another would be finance, where like we already talked about loan applications and fraud detection, but telling that somebody is a fraud without ample evidence is a lawsuit waiting to happen. If a bank just used an AI to reject a loan and the dude figured out that the AI did it, if the bank is not able to provide sufficient human reason for the same thing, the bank is probably paying a very huge fine in terms of lawsuits. So explainability there is super important. I worked on a few very interesting use cases in the FinTech lab. Another being in logistics, there are like shipping routes and delivery schedules. One example for a ship is if it's supposed to travel from India to, let's say, Brazil, a lot of coal and raw materials do the routes. most of them stop at South Africa, the port in South Africa, like Cape Town or Port Elizabeth or Coega, a couple of others. But there are a bunch of other ports around the region. Like you've got ports in the Maldives, obviously, but you also have ports on the other side of Africa. Uh, all of these other countries like Tanzania and all the others who also have ports, but because South Africa is what has been used in the past, ships just continue going there, even if the other ports could like maybe do a better job. The problem here becomes the port that's getting the traffic just keeps developing again and again. The ports that don't get traffic because they're only getting very few ships, they don't develop at all. It's basically the same as the wealth gaps in like almost all developed economies. And dealing with it, at least our system tries to say that like you've got these African ports as well who've had like relatively decent KPIs in the last year, and you could try going there. I think like most companies should probably begin trying to find these like local alternatives that might help a more fairer world. Another being like, yeah, in terms of general challenges and limitations. So you've got complexity, computational overhead, context sensitivity, and there are also adversarial attacks, which are crafting attacks to overcome what the AI does. In the days of like initial releases of ChatGPT, we used to have like people creating prompts that if you used could basically like jailbreak GPT. And if like uh, certain content like political content or religious content, the AI was specifically told not to talk about, with the sort of prompting and adversarial attacks, you could get the AI to talk about it. It's very important to make sure that this doesn't happen, but it's more difficult done than said. And then another part is choosing the right XAA tool. You've got a bunch of different options. So you'll have to consider the you'll have to consider the complexity, the user, like if it's an engineer versus HR or sales, the kind of output for explainability can be different. Like if it's a data analyst, just printing out sharp values of features is enough. We can export it into SQL or Python and do something up. But if it's a HR, they probably need the actual English to come out. And then you have to find the right metrics, like defining what you mean as responsible is super important. So it's very subjective, but at the same time, it's a very interesting domain. And the fourth one being continuous learning, like every year or every 6 months, try to spend some time figuring out like what has changed and then try improving it. And some of the simpler best practices, one is document everything. So I usually spend around like 10 to 15 percentage of my workday on Notion, just typing stuff down. When I initially started, it felt really bad, but at this point, it's become kind of necessary. So that's one. And another being like regular validation, always revisit your assumptions and also keep a human in the loop, which is like a extremely underrated but very effective use case. As long as if one human revisit the AI every couple of days, can usually find what's wrong pretty quickly. Um, I'll now talk about responsible AI at Podcast itself, what we have committed ourselves to, and we continue building by. It might sound like a plug, which I guess in a very small way it is, but at the same time, we are kind of committed to building like very responsible AI. It's not just principles, it's our business imperative. We make sure we include it on all our product offerings. And our approach includes like validating data from multiple sources, making sure the models are rigorous and transparent, and also make sure we've got like multiple automatic validation tests running at all times. A couple of our real life use cases that we've faced that I'd like to talk about. One was being when we were building our initial models. This was like a year and a half to 2 years ago, I guess. So when we were building these initial models, because we just bought data and we'd begin building stuff, it used to work so much better for like the bigger ports. Like I told you, example of South African versus the ports around them, and a couple of the other things. And the impact of this, as I told you, is like the South African ports keeps getting better while the other ports don't, and it's basically a sort of wealth inequality in the region. So our approach, a couple of our approaches is one, we email the ports individually to like ask them for data. They used to share it in CSVs and a bunch of old Excels, like 1998 Excels, and we would import them and try to use that data in our models as well. We also have a sharp value based methods like identify what's wrong, and if there are skews, we try to fix that. And using this, our accuracy for like the smaller ports have improved quite a bit, by like almost 15%. We're over 90% for like small ports itself. I mean, our bigger ports are still better because we've got better data there, but we spend more time on the smaller ports so that we're at least far that way. Another would be auditing and accountability in invoice reconciliation. So this is where shipping, because it's international, you've got different parties in different countries going into legal contracts. So at this point, it's a pretty complex process. So we are basically working on a couple of product avenues. Like it's still in R&D where we're trying to like build models that could solve this. And yeah, data privacy following the regulations are a big part of this because a lot of this data is sensitive. Another would be like data privacy and security, which does not seem like an AI thing. It's more of a cybersecurity thing, definitely, but it also deals a lot with responsible AI and data, and access controls are important. So a couple of things that we've got is like we've got extremely granular access control, like only authorized personnel get to see like certain types of data. And even after the data is seen, there are some data that our models can see only once, forget, and the models can only access the data if they're in a very specific Docker instance that has already gone through a bunch of validations and a bunch of other such like extremely granular access controls. Another being like data sovereignty. So thankfully, AWS has got like data clusters in like most major places around the world. So if you've got a Europe client who wants to keep everything in Europe, we are happy to spawn an instance in Europe to keep it. It is more expensive for us. Keeping everything in one place in Singapore or in America is going to be cheaper for us in the long run. Because like if there are different regions, when we want to consolidate some stuff, cross-border network charges by AWS is like very, very expensive. But we still offer this option because at no extra charge, because we find it to be like an important part. And doing GDPR and global compliance. So you've got the GDPR in the EU. You also have the Personal Data Protection Act from India that got passed this year. The act is not as powerful as a bunch of other acts, but definitely like a promising step forward, I'd say at least. Data minimization as well, where we don't keep unencrypted data if we don't need it. So a lot of our data, once we've used it, we usually just purge it again so that it goes back into like encrypted data lakes. And we also have like a bunch of regular audits. So we do it like once a year. I mean, from the time I've joined the company, we've only done it once, but we do it once a year. And doing all this and being transparent about it has helped a lot in customer trust and business growth. Like, uh, given our focus on explainability specifically, if so among our competitors, we've got that one as a pretty big advantage because we're able to explain why something's not working or something's delayed. It took a very long time to get it right, and we had to spend like a lot of R&D in something that wasn't going anywhere, but the light at the end of the tunnel was definitely worth it. Another being like now probably look at like policy and regulation in responsible AI. I mean, it's like such widespread adoption of AI has only been around for 2 years after ChatGPT, but even before that AI was big, companies just weren't taking it as seriously enough. Now there are like a few new people. The EU is the leader, which I guess everybody has to agree. Like they are probably working the most towards like ensuring fair AI. In terms of examples, like there are two big things. So the first one was the GDPR, uh, which was like the original data protection law that came out, and a lot of countries just copied most of it. Uh, yeah, I shall deal with I shall bring up context sensitivity like towards the end. I'll remember the question. So in terms of GDPR, there's a bunch on data rights and algorithmic transparency, and there was one very, very interesting small nugget that most people don't go to court for, but it's there in the law. You can download it as a PDF. It's not as big, and even if it is, you can just put it on Claude or ChatGPT to ask it to generate a summary. So they have a very small clause called the right to explanation, where if the AI or anything else, if like any algorithm made a decision, if the company is sued, the company cannot use the algorithm to, it cannot use an algorithm. That has to be an independent human who should be able to arrive at the same output with a detailed explanation. So it's a small but extremely interesting section of the GDPR. And the another thing that's just coming up is the EU AI Act. So it's a pretty comprehensive AI framework, and it is super important for like high risk AI systems, specifically to do with like LLMs. You've had like multiple huge names in the generative AI space go to the EU in the past 6 months to talk about this. So yeah, that's coming up. And things that implementation challenges, there are a couple. One being cross-border data flows. So when our AI model is like, so if I'm working from Singapore, but my client's in the EU and I have to keep everything in the EU, but that also brings like some legal gray areas where I'm technically working in the EU, but I'm working from Singapore. It's still allowed at this time, and Singapore still has an agreement with the EU, but these sorts of legal terms might become more complicated in the future. And if you pick data from India, even after like, anonymizing it a lot, if it was used to build a system in the EU, is Indian data being used for EU models? So is it breaking the Indian Consumer Privacy Act? Uh, it's a gray area. The courts still haven't decided if it's a yes or a no, but it's definitely an interesting point. And another industry-specific hurdle for us specifically has been in the maritime sector. We have a lot of regulation, old regulation. Like if you take the Europe, London, for example, there are still laws that were written in the 1700s that apply for our industry. And if we build AI models, they have to follow those laws as well. There are some people who are trying to overturn them, try to build a more compatible future thing, but these problems exist. Every industry has its own set of problems. Yeah. Another would be like best practices for responsible AI as like a more detailed flow. So one would be representative data sets like garbage in, garbage out, which is like a lot in coding, but in data specifically, make sure you try to collect data. So in data analysis phase, or even after building the model, like if you built a bad model, it's not wrong saying you built a bad model as long as you recognize it. So make sure you find alternate data sources. We've had a lot of success with it where if we have bad data, reaching out to people through emails or writing contracts and stuff has allowed us to like get new data, but putting the new data in the public domain is not easy. So it's definitely a difficult task, but building something like that, I believe, is like a basis of building responsible models. Another being like audits, like I'm telling ethical audits, but even just basic model performance audits where if you built a model in 2019, let's say, pre-COVID, most ships used to travel through the Suez Canal, and that was what your model was built for. And that's what like your model was telling people to do, and that's what like people were using your model for. But if you remember, like 2019, 2020, there was a ship that blocked the Suez Canal called Evergreen. And after it blocked the Suez Canal, so many ships just got delayed. A bunch of them went around Africa, a bunch of in Cape of Good Hope. Other people went around Cape Horn in South America, and others used the Panama Canal. But if your model was still believing that Suez Canal was the correct route, it would have begun giving like wrong answers. And if people did not know that, if they did not know that wrong answers were being given, yeah, if wrong answers were being given, then that basically means your AI is not doing its job. It's not really fair. So making sure like if something happens to our model, like when we build our models, we've got like a bunch of like safe assumptions that we take. And if something happens to the assumptions, our UI automatically begins showing a warning signal where like it happened after the Houthis hit the first ship, after like during like the Houthis hit the first ship blocking the Red Sea. We began showing like a red area near the Red Sea in our UI to make sure that, you know what, our systems, we still have some methods of workarounds to give accurate answers, but we're not 100% sure. So being extremely transparent there is important, which is the same thing like stakeholder engagement. Like always make sure you talk to your stakeholders about what you're doing and document everything. So whenever you talk with people, just have like an AI note taker, which has been like super useful. Like my company is right now using a tool called Firefly. Every call with customers, investors, even between ourselves, we've got Firefly that takes notes, summarizes the notes, and puts them into HubSpot so that we can always remember what we talked about. So that's a pretty useful tool to use. The next one would be continuous monitoring. So you have to, one thing is model drift, uh, even seasonal model changes, but model drift as well. So for every small port or major port, we've got like extremely small micro models, each worth like few MB basically. And all of these models are retrained every week on the past few months of data. But this also faces a problem where assume Chinese New Year comes around in China, where all production stops in China. And I'm only using the data from the past 2 months from Chinese New Year. It will technically mean like I'm not actually anticipating what will happen in Chinese New Year. To get the context, I would have had to go back 1 year or 2 years in the past. So ensuring that these sort of contexts are kept while training the models, while monitoring model drift, where you have like test sets that you constantly monitor to check like what's actually happening. So we also try to monitor our models against our competitors. We bought a few of their API keys and monitor. Everybody in the industry does it with their competitors. So it's like basically a hidden secret at this point. Open secret at this point. Yeah. Yeah. Also track fairness metrics over time. So we've got a few models which track our accuracies for big ports versus small ports. And if it diverges by like more than certain limits for more than a certain amount of time, we immediately flag the ports to look at like why we're not getting what we need. So that's another thing that's helped us for fairness, and log everything. We pay a lot for logging, which is also painful, but visibility is a lot more important than just doing stuff in a black box. Like visibility is super important. So yeah, like we reduce the window for which we'll have the logs, but we'll still keep as many logs as we can so that we can always look at exactly what happened. So you monitor, you evaluate, you improve, and you just keep doing it. You never stop. Yeah. Key takeaways, regulations, follow them. Data diversity, super important. Documentation helps you. Ethical considerations have to be revisited, and keep open channels of communications with your stakeholders about your AI itself. Yeah. And now I'll just talk about a few research papers. So these are just like bigger research papers that I picked out, like the most common research papers you can find in explainable AI, basically. There are a lot of others that I'd recommend you guys check out on your own. One would be a classic, The Mythos of Model Interpretability. So it's just about like uh, a process framework for telling if your interpretability is correct. So you say this is why something happened, but is it actually why? Like, are you actually interpreting accurately is one thing. Another would be fairness and abstraction in socio-technical systems, where it says like fairness is not really technical, it's more social, which is where I was telling about like the port problem. Like you've got ports in South Africa and you've got ports next to South Africa. Ports in South Africa and Madagascar, let's say. Ports in South Africa get more ships because they have been a port for longer. They were under well-developed nations, so they already built trade routes. But all of that, if you just look at it from paper, it looks fair, but from a social context, it is just increasing wealth inequality in the region. So just looking at the data is not enough. So social context helps a lot. And a few major buckets of research areas, at least, uh, that I think like we can bucket them into these few areas, and then you basically read up on the area that you find interesting or your work works on a lot. So one would be model explainability. So where I say like, why did this get delayed? Like a couple of very interesting later things. One is attribution methods, which is kind of like sharp, but like in a reverse way, where you're like you get all the, instead of just getting the weights and then going from that, you get the outputs and then you try to attribute the output to certain features over others. And in terms of like document answering and stuff, you've got like an attention visualization where you see whether like more time was spent by the model on certain sections of the text, which basically led to like more bias towards like those sections compared to others. Counterfactual explanations as well. Another being bias mitigation, where making AI fairer one set at a time. So there are a whole bunch of techniques here that different companies are coming up with all the time. So you've got debiasing techniques in the data itself and in the model. You also have like fairness metrics that you can define on your own, or there are some well-defined like general fairness metrics. At least in the more common things you think of, there are like complete frameworks for just talking about things like gender biases in data. Where using those will like, it won't solve the problem, but it'll get you a long way. Another is privacy preserving AI, where you've got federated learning, differential privacy, and encrypted computation. Federated learning is where you're learning, but not really sharing the data itself. So this is an aspect where like you could train a model in EU using data in India without sharing the actual data. Like, it's a interesting space. And differential privacy. One of my professors, Riza Shakri from NUS, like he's one of the OGs in this specific place. I attended one of his class called Trustworthy Machine Learning. He has a couple of blog posts on the same thing out, which I'd recommend people interested checking out. And in terms of staying updated, I follow a couple of blog posts, couple of people on LinkedIn, but I don't open LinkedIn much. So I mostly follow it by like keeping in touch with friends who follow this. But in general, you've got like a few conferences that are like specific to uh, responsible AI itself. So you've got the Fairness, Accountability, and Transparency, the AI Ethics in Society, and Europe has a separate stage on just ethics. And then you also have a few organizations that do the same thing. Yeah. And with great power comes great responsibility. And the papers aren't theoretical. So you basically look at the papers. You don't need to implement them exactly as they are. You just take the soul of it and you try to build it yourself. Your stakeholders will thank you later. It can be for different reasons. It could just be like, I don't know, societal concern, which is like a fair enough reason on its own. It could be a profit-based concern, which smaller carriers have preferred us over our competitors because we spend time talking to them. It can also be regulatory concerns. Next year, India could just bring a new law similar to the EU AI Act, and then re-implementing everything might be more of a pain. So when you begin building itself, maybe it's better to like do it properly. So yeah. So in terms of responsible AI adoption, okay, so I have been going quite fast, so I think I could finish a bunch of these things and have like around 15 minutes for questions. So responsible AI adoption, a bunch of major tech companies have already begun adopting their own versions of responsible AI. So Google has AI principles. I think they have 5. Microsoft has the Azure Responsible AI Framework, where they've got 6. Cisco has 6. Meta has 6 or 4, I think. Altation has 7. Everybody has their own different thing. There are also other people who formed consortiums. Like there is a group called the Responsible AI Institute, where if you go into their website, you basically see like it's a responsible AI framework think tank that basically is formed by Amazon, BCG, Shell, Genpact. So you've got like big companies in every industry coming together. So they're like one interesting institute, but I still prefer like the Azure Responsible AI Frameworks white papers over the Responsible AI Institute. I went through both like a couple of days ago, and Azure, I felt was like, at least like was more to the point. And if you're starting off a project and how you start, the bigger companies already have frameworks and they've already put them out. In coding, copy pasting is not the exception, it is the normal. Like that's what we do everywhere. So it's not wrong to copy paste this whole thing as long as you like, tweak it as you go. So pick any major framework, like just read about a few major frameworks, just a summary, and pick the one that you think like suits your use case the most. Then if you begin at the start of the project, it's probably going to be like, it'll take longer, but it's going to be easy. If you do the middle, it's going to be like difficult, but still doable. But after you finish everything, like it's impossible to integrate responsible AI then. Like you could do some aspects of explainability, sure, but dealing with biases and all of that, like you wouldn't have any benchmarks from the beginning. So it would just be more difficult. And in terms of frameworks, you've got like tens of frameworks. Like you go to GitHub and you just put the tag responsible AI framework, you get like hundreds of repositories there. Here are a couple that I have looked at and that me or my friends have used, and they work well. So the Responsible AI Toolbox by Microsoft, it's a pretty useful toolbox that I personally have used in a few of my projects. Like when I bring my current R&D work to production, it's probably what's going to go into production with it. Another is the IBM's AI Fairness 360. So I used this a year ago during like one of my college presentations to like work on fairness, like dataset fairness and bias mitigations. They work really well. Microsoft also has the same thing. And we've also got like the Open FGA, which is like, it was developed by a group of open source people, but they eventually gave it to like the Cloud Native Computing Foundation for maintenance. So the Open FGA basically is a framework for like specifying access controls for data. So both relationship based and attribute based access controls, which are like super useful if you're like working with very sensitive data and you need to build systems which accesses these data both for like training, testing, and during production. So depending on the use case, yeah, the tool completely differs. And because I've used a little bit of like the Microsoft Responsible AI, I'll just talk a little bit of, I'll talk a little about what it actually does. So if you want to get started with it, if you're on Python, most of us hopefully are. I hope none of you guys are like still working on R. It's a good language, not to say, but still Python's better. So you just need to do pip install responsible AI widgets, and you'll just get like a bunch of dashboards and stuff that you can probably just keep adding on or like installing more and just get started. So in terms of their AI principles, so yeah, Microsoft has 6. So they've got fairness, reliability, privacy, inclusiveness, transparency, and accountability. So in the responsible AI toolbox itself, they've got like 5 separate tools that you can use. So the way it works is your inputs and your outputs and other things as well. You convert them into NumPy ND arrays and you can pass it to the responsible AI API at constant times with timestamps and other things and basically monitor it on dashboards. I think they allow pandas, CSVs, and a couple of other formats, but I've usually just used NumPy for almost all things. So yeah, I think they also allow PyArrow, but I just use NumPy here. So you've got a responsible AI dashboard, which is like an overall dashboard that works for like a broad thing. You also have an interpretability dashboard that offers like interpretability tools. Like you can install Sharp and Lime, but this is a little bit more. You've got a fairness dashboard, an error analysis dashboard, and mitigations and tracker dashboard where you can track certain stuff. So in terms of the responsible AI dashboard, which is what like I've at least used, so the first part is like, so you've got like different things you can do in the dashboard itself after all the data is in. So you can identify stuff like identify fairness by, I mean, it's basically just frequency counting and stuff, but doing it in the same place works. So you do that, then you diagnose whether it's working accurately. Then you try to work on methods to mitigate it, and then you basically go around mitigating it. It's a loop. but it works. Like, I mean, you could do it on your own, just writing Python scripts. It's definitely doable. And it's probably going to be harder to get started with this. But in the long run, having a framework that somebody else maintains and accounts for like logics is more useful than building everything from scratch yourself. That's why computer science grows this fast. We don't redo every single piece of code. And now I'll go through a case study, a very, very basic case study that, I mean, the scenario was just generated by AI and I just developed a few slides on it to talk about how this would work. So it would be like a bias in loan approval systems. We can imagine it being in India. So assume that a major Indian bank built a complete AI system for loan approvals. After 6 months of deployment, they go back uh, and they look at like there has been lower approvals for tier 2 or 3 cities compared to tier 1 cities, and then higher rejection rates for smaller business owners versus salaried employees. But in terms of accuracy, it's still at 95%. So they probably just looked at accuracy for 6 months. It was still at 95%. Volume was still stable. So they thought everything was working as it was. So here were a couple of the mistakes that they did initially. So here are a couple of the mistakes that they probably did first. So waiting 6 months to monitor stuff other than accuracy was a very bad idea. They should have had like a much better monitoring system in place. And a bunch of the other things, let's just analyze what they might have done. So a couple of questions that you probably initially want to begin analyzing is, could there have been algorithmic bias here? Like, is the model itself to blame? And is there any logical reason why like a human would make this mistake? Because an AI could also go the same path. And what sort should we have prioritized when building a model? Like, so here is a problem with explainable responsible AI a lot, where in the quest to be fair to everybody who uses the model, many a times we might just end up reducing accuracy. And to an extent, I would say that that's okay, but customers still pay for accuracy. Saying you're 91 versus 97 percentage has a very big difference in a pitch. So, but still, for a bank which is already big, works a lot, they should have like at least analyzed accuracy versus fairness more. And another would be like, what is fair? Like, what is fair is basically saying like justice versus equality versus equity. So there are a bunch of different memes about it. I would have liked to open something, but yeah, I did not find something. But the idea is basically, should everybody just get the same loan, depending on some very, very basic factors? Or if not, should tier 2 and 3 cities get more loans? Because that's how like development happens there more. But that's unfair to the people who move to tier 1 so that their lives will be better. And a whole bunch of ethical questions like this. Give me a minute. Yeah, sorry. So one approach that, I mean, it might be a simple approach that a bank actually tried, I think, in Europe years ago, where they just identified the features that were causing these biases. Here, it would have been business type because salaried people were getting more loans compared to business owners, and location because tier 2 or 3 cities was getting more than tier 1, less than tier 1. So idea is, if they can't see these biases, then they probably can't see it. So if you can't see it, then it cannot be biased. It's kind of like our academic peer review system where papers just go to others without the authors. If you don't know who the authors are, you kind of assume that it's not working. But same as the peer review system and other systems, there are issues. And in banking, it's bigger issues. So one, proxy variables will still remain. Like in a tier 2 or tier 3 cities, income sources would have been smaller They might not have like accounted for everything well. Like digital spending won't be as high as tier one cities. So all of these would basically mean like all sorts of like proxy variables will probably end up still giving the same data, will still end up leading to bias, and it would basically lead to underlying bias while losing very, very important data. Like knowing that somebody is from a tier 2 city is important. Like it's a very, very big part of information. Just because that information could be used in a biased way does not mean it's bad information. Knowledge is never bad, only the use case of knowledge is bad. So if a bank did this, most likely nothing would have improved. They would have probably taken another 2-3 years to like figure it out. So that's probably what would have happened. So following a more structured approach, extremely simplified, I know, but still. So one would be analyze the training data of the bank, like look at like what happened, and also look at like feature importances, correlations, and a bunch of other things. So if you look at root causes, one would be in terms of data issues. Because more people live in tier 1 cities and more people are banked in tier 1 cities, and more people know about these avenues for loan, like avenues for formal government-backed loans in tier 1 cities compared to tier 2 or 3, a larger data set would have eventually come from tier 1s. So this would mean we've got a limited, small historical data set for small businesses and like tier 2 cities. And this hurts like how much the model is going to understand. And if it's a model like a tree-based model, if only 5% of the data was, let's say 5% of the data was from the villages, and among the remaining 95%, if it found a split in a tree, that would basically put 85% correctly, but all of the tier 2 and tier 3 data sets would eventually just go to reject file. Accuracy is still at 85%, which is good, but nobody in the village is getting loans. So that's like a societal root cause that statistics is probably not telling us. And another would be like feature engineering. So we see that like the models just preferring income stability metrics over like profit metrics. So it could be like even if you got like a smaller salary, it valued it more than getting like bigger business turnover. And another very likely thing, which is a real issue that I worked on, at least in like Southeast Asia, was formal credit scoring systems, where like the formal credit score system just works with people with a credit card. And even if businesses in villages had credit cards, like people in villages wouldn't have. And that would have like impacted credit scorings, and that would have basically like hurt their chances at getting a particular loan approved. And solution framework, important thing with solution frameworks, you don't have to fix the root cause straight away. Like, do not try to just immediately stop it and just rebuild the full solution. It's important to just go for the low hanging fruits. So you pick the things that are just easier to do first, and then you keep moving up first. So short-term fixes is you retrain, but you do stratified sampling based on location, where you ensure that like I mean, specifically if you're building a tree, like you do something like k-means sampling of sorts, and you make sure you pick like enough people from tier 2 and tier 3 and small businesses and everything, and also try integrating some sort of alternative credit scoring feature, like maybe partner with a company like Cred, or I mean, I'm not sure. No, Cred only allows you to like repay credit cards. So in Singapore, started in the UK, there's a company called Revolut, which I think is there in India as well, where they allow you to give your kids like credit cards as long as they're over 10, where you get to set like extremely small limits, but they tie it to the child's government ID. And eventually, by the time the child turns 18, he already has a healthy or bad credit score. So you maybe tie up with companies to do that, or you tie up with like government entities, tahsildars, panchayats, and stuff like that to like ingest data for alternative credit scoring. Like, does he have a good reputation in the village? Things like that. And also constantly do regular bias audits to check if these short-term fixes are fixing anything at all. And long-term fixes would be like make sure we do targeted collection and like smaller villages. So if you're just a bank for Tier 1 cities, you probably have enough data on your own. But Tier 2 or Tier 3 cities, maybe you just share the data with other banks so that everybody gets more data to work with. And look at domain-specific features. So maybe if you're targeting like farmers, you look at like crop yields and like rainfalls and things like that to grant loans instead of like just the very basic features that you already had. And have a human in the loop reviews. It always helps. If you can't have them every day, have them once a couple of days at least. And implementation and monitoring. So approval date, make sure you monitor approval rate disparities, default rate consistencies, feature importance shifts, model drifts, model performance in multiple segments, business impact metrics in terms of are you still making a profit? Because if you improve the AI system and you begin making a loss, the AI system is useless. So money is first here still. And customer feedback analysis, which is relatively subjective, but you can still ask people who went through the system to check how it works. And key takeaways here: bias is usually due to like data or human biases. Like the computer is biased because the people who built the computer were biased in the first place. So in the way that we fix the bias in the computers, we can fix the bias in the people as well. Like, so that's kind of how it works. So hopefully that pays off in the long run. And simple solutions will just create new problems. So just work through solutions. Like Occam's razor is almost never applicable in AI because like simple stuff, if it's simple, somebody already tried it before you and most likely failed, or you would already know to do that. Balance between accuracy and fairness, depending on a use case, this changes a lot. And if your fairness requirement is extremely high, most companies at this point for super high fairness requirements build models that focus on accuracy and basically deal with the bias by having a very huge human in the loop system. A lot of banks do that where they've got automated systems that already do a bunch of parameters and then AI, and then there are like human people who need to verify that before it can actually be applied. There is like a talk by Jamie Dimon, like the 20-year-old, no, like the dude who's been the CEO for 20 years, like Morgan and Chase Bank, the biggest bank on the planet. And he had like a conference on AI where he was talking about how they're trying to merge them together. Yeah, it's a very interesting talk for people who'd like to watch that. And continuous monitoring and iteration is obviously crucial. And consider both the technical and social aspects. Like the technical aspects would just mean profit, but if you just focus on profit, it's likely that you might just lose consumer trust, which is kind of what used to happen in which I mean, we are seeing an extreme form of loss of consumer satisfaction happen in the US right now, but there are like less significant but still pretty bad things that could happen. So that's about it. So I've got 15 minutes for questions. So I did go through a lot of slides very fast. Okay, I've got one question already. Context sensitivity is one of the challenges. How to make XAA system which deal with this challenge? Do we go for user-centric requirement engineering for XAA at a design level? So I would say this would change depend on what sort of AI we probably build. So if it is like relatively simpler or narrower models, like you could basically pick a very small, I mean, even in Gen A, if you're picking a very, very narrow model and you have enough data to fine tune it, you can probably do it without like, yeah, you can probably do it without any sort of like actually going for like very user specific requirement engineerings. And it's probably easier in stuff like decision trees or like classical ML algorithms. So in classical ML, to remember context, you can just write rules for context as long as you've got like as long as you have like a domain expert to help you. like we work, we used to work, we still are, it's still not out and we're not sure if the product's coming out, but we used to work in like a legal thing with like for building like a legal decision path system. I can't talk too much because like I was under an NDA at NUS when I was building this, but we just had lawyers we would consult with. And when the AI used to come up with, we just try to find the bigger or the more like viable path of decisions that it could take, and just consult with the lawyers whether there was like some problem with it. Like it only works for extremely constrained use cases, sure, but once we knew that certain things just couldn't be done, we just add them into rules even before the training began. And that would just deal with context sensitivity in those use cases. If you're talking about it in the context of Gen AI, then most likely, yes, like you'd have to go for like a, it's very difficult with Gen AI because like people usually build Gen AI applications for very general tasks. They don't try to like make it like super specific. So even if it's context specific, a chatbot is probably going to be like, a chatbot about, let's say like about cricket. But talking about cricket is still very, very general. So it's still possible for hallucination and other stuff within it. So I'd say like the way we'd approach it would probably change on like what we want to end up at. But yeah, user-centric requirement engineering is probably gonna, you don't need to go all in on it for certain use cases compared to others. But yeah, it's still an open question depending on the use case. Would you like to give me more context and I can answer? Dr. Sony
Participants,
Sweta.
you can post your queries. And Dr. Sony, sir is asking you to give him the other way of answering the same question. Kindly post your messages in the chat window. Meanwhile, I'll try to unmute you. Dr. Sony. I hope now you are unmuted, Dr.
Yes, ma'am. Good
Please
evening.
go ahead.
Sir, actually, most of the speaker of this responsible AI FDP, they are talking about the model explainability, accountability, and all. Means after building the model. But what about the requirement engineering once we will at the design phase? If we are also considering the users, different kind of users, what their requirements are. So is it possible explainability means requirement engineering, user-centric requirement engineering for the explainability? Is it required as a research problem statement?
So I'd say like explainability. So depending on the use case is still what I would say. But
Like suppose in healthcare, so many stakeholders are there: patient, doctor, nurse, management, administrator, and everyone want explainability in their own perspective or own way. So at the time or at the designing phase, can we do some different kind of requirement engineering for the spatially explainable AI? Is it required?
So okay, so just in terms of I'll answer it with the hospital context itself.
Yeah.
So an idea would be during the requirement phase, it would make sense to talk to all the stakeholders to figure out what sort of like explainability they'd want.
Yes.
But trying to bake in different types of explainability into the same model is still going to be difficult. So one example that I give you, like, okay, let's say it's for cancer identification, a pretty common or popular use case at this point. So you'd have what the radiologist wants to look at. So a sort of explainability for the radiologist,
Yes.
a sort of explainability for the oncologist, a sort of explainability for the hospital administrator, and a sort of explainability for the nurses. Like all of them require their own, so all of them need to understand different things, right? So different explainable aspects from the model itself.
Yes,
I'd say the way I would approach it, at least, it's quite new to me, but the way like I'd approach it is once I have all the sort of explanations I need out, I'll try to draw a graph to figure out like what explanations can come from what explanations. Like
yeah. So this is part
you
of the
have the
requirement engineering of explainable AI.
what do you mean?
So
Uh,
these are the different kind of explainability which is required by many of the stakeholder that will be part of the requirement engineering for explainable AI.
It'll be part of the requirement engineering for a product itself. Like, so
Okay.
AI becomes a part of the product. So you could say it's part of the explainable AI itself. But the way I would like encourage people to look at it is you've got a product or like a product of any sort where it's a product that's going to get plugged into a hospital to basically look at radiology reports and figure out cancer. And different people are going to access it. The AI is a very large part of the product, but it's not just that. You're going to have the data side of it, the hosting side of it. So you look at it as an engineering product, and explainability becomes one of the requirements of the product itself. And then when you begin designing the explainable AI, the AI models, you can basically translate the product requirements into like what sort of requirements the AI would need.
Yeah. Yes.
But yeah, I guess like we're getting at the same thing, where for a case like this, it would make sense to like sit with most all stakeholders to create like uh, basically create something like a requirement collection session where you maybe get everybody in the same room or meet everybody separately and talk to all of them about what they expect out of the product. Then you probably bring everybody into the same room so that, for example, right now, how does a hospital work? Like the radiology report, the radiologist sees the radiology, writes the radiology report. Then the oncologist sees that and writes something. And then the nurses use the oncologist's report, and the hospital administrators also use the oncologist's report. So technically, for the model, if you just build the model to be explainable at the radiologist's point, you can maybe build a much more simpler model, like a meta model, like a very basic tree model or something else, to convert the explainability part, the report of the radiologist, into what the oncologist needs, what the other people need. Like asking the AI to do everything at making the original model explain everything might become more complicated. So it's easier to split it into steps and just do the simplest part there.
Thank you, sir. Thank you.
Yeah. Anyone else?
Very beautifully answered, sir. Is there any other questions? Participants, kindly post your queries over here. You can post it in the chat window, or you just tell me so that I'll unmute you. We have a question here.
Is there a way to prevent hallucinations in AI? Very simple answer, no. There is a paper by a couple of researchers that came out like 5-6 months ago, which mathematically proved that hallucinations will never stop. Specifically in like these generative AI use cases, like in transformers, encoders, like most complex deep learning models as well, hallucinations will exist. So unless the model is super simple, hallucinations are not something we're going to be able to prevent. There might be ways for us to like work around hallucinations, try to reduce them as much as possible. But beyond that, we can't really do anything. Like better models get better at understanding context, or you basically figure out input methodologies. Like for example, if you work with Claude, which is Anthropic's AI equivalent of ChatGPT, I am a believer in Claude supremacy. The model's better than most others in creative tasks. For Claude, a way to prevent hallucinations is because when Claude was feeding inputs to their training, they were using JSON based slash Google search indexing based method of training data. So if you wanted to focus on a very specific query, you enclose it in curly brackets. Or if you want a particular phrase to be exact, you put it inside double quotes. These sort of tips on how the inputs went into the model might help us figure out like how to maybe reduce hallucinations a little bit. But beyond that, it is still going to be difficult, to be honest, to like reduce hallucinations by a lot. A better method would be, if your task is extremely concentrated, fine-tuning the model will probably help. Like you can fine-tune something like Gemini 1.5 Flash, which are like their cheaper models, where like you get like 10 million calls, 10 million tokens per dollar or something. So it's a very cheap model. You can basically take that model and fine-tune it, and fine-tuning will reduce hallucinations to an extent. Other methods would be validations. So after the hallucination is done, after the output is done, you can make another call to an LLM, or you can have like more general calls to basically check if what it's telling is true. So I know a friend of mine who is like creating like a startup in Vietnam right now, where it's basically a tool with generative AI to teach people SQL, like teach people in schools SQL. So when the AI comes up with SQL, what he does is he's downloaded like a whole bunch of SQL databases and like other things. And what it is, when the AI comes up with an SQL, depending on what the input was asked, the AI comes up with an output. The output is taken and executed in the SQL DB to figure out if the output is correct. So you can try, or at least a partial of the output is taken to figure out if it's correct. Like there might be like some ways to reduce hallucinations, but they're never going to go away. Yeah. Any other question? We've got
Thank
3
you. Thank you,
minutes,
sir.
so,
Let me check for any other queries on the chat window.
yeah.
Probably if there are no further queries, or if you have any queries in the future related to this session, you can put it to the registered email ID of the FDP, so that we will take it forward to Pichayapan sir and get back to you. And it gives me immense pleasure to see my student taking a class on an advanced topic, and it's a very pride moment, right? So formally, I extend my heartfelt gratitude to Pichayapan, data scientist at Podcast, for accepting the invitation very immediately. And that shows like how much he is bonded with PSG Tech, especially with the Department of Computer Science and Engineering. Thank you so much. Irrespective of other commitments from that side, you have accepted and you have done a very great job for us. And we have got great insights from you. Thank you so much.
Thank you.
The attendance link will be posted in the chat window.